So number 28 says to solve the system of inequalities by graphing. So what we want to do is graph both of these quadratics and see where the overlapping shaded region is. So I'm going to go ahead and do this one first in blue. I know I'm going to have a y-intercept at -4. That's pretty easy to see. But I want to find my 0. So I'm going to go ahead and factor this. So -4 and a 3, probably a 4 and a 1. Let's see here, I have to make a +3 and a -4, so I'm thinking that's going to work. Okay, so I want y is greater than, if I factor this, I would have an x plus 4 and an x minus 1. So therefore my zeros are going to occur when x is equal to -4 and when x is equal to +1. So here's +1, and then here's -4, and then the sketch of my vertex is looking something kind of like this, like if I had to make a guess. Okay, so it looks something like this, and I could find the vertex by taking -b over 2a and then seeing where that point would be. But notice that my graph is dotted because it says strictly greater than. So I'm gonna go ahead and take a test point at 0, 0 and see what kind of statement I get. So is 0 greater than 0 squared plus 3 times 0 minus 4? So is 0 bigger than -4? That's of course a false statement. Oh, excuse me, 0 is bigger than -4. That's a true statement. Jeez Louise. So therefore I want to shade everything that's on the inside or everything that contains that point 0, 0 because 0 is bigger than -4. So this is the first picture, and I can verify that by looking at Desmos here and then graphing it, that yeah, I have everything on the inside. The next thing that we're going to do is we're going to do this part in green for you so you can see a different one. So I want -x squared minus x plus 2. So we're going to get rid of all this, and we're going to do the same kind of analysis on this one. So if I have y is less than -x squared minus x plus 2, all right, that's the same thing as saying if I wanted to multiply everything by -1, just to get rid of that or change that sign, you could do that, but it might confuse you, so we'll just leave it the way it is. So we'll go ahead and factor this. Okay, so I'm going to take -1 times my 2 on the back that side there, so I get -2 and a -1. Don't forget you have to multiply this one by that one to get that. Okay, so I would get a value of, sorry, my computer kind of went on the fritz there. So anyways, this is going to factor to -x minus 1 and an x minus 2. If you go ahead and FOIL this out, you'll see that this factors back into that part right there. If you can't see how that works out, one thing that I would suggest is just keep this equal to -x squared minus x plus 2, and then go ahead and factor that normally like you would with a diamond problem. But anyways, this tells me that -x minus 1 is going to give me a 0, or an x minus a 2 is going to give me a 0. So this tells me that -x is going to equal +1, so x has to be -1. So at -1 I'll have a 0. And this tells me that x is going to be 2. And at 2 I'll have a 0. And I know this thing opens down, so this graph looks something like this. And I want everything that is less than that, so I'll go ahead and test 0. So is 0 less than the negative of 0 squared minus 0 plus 2? So is 0 less than the number 2? Yes, 0 is less than the number 2. So therefore I want everything that's below this. And of course the answer to the problem is everything that's in between. So we want all this shaded region here. So this is what you'd be expected to do on the test. What it looks like a little more cleanly is this part right here. You can see that the shaded region inside here is the one that makes both these inequalities true. And that's AD number 28.